Sterling conforms to a national standard that was found to be totally pure and safe for use in potable water systems. So any metals that are in the solder will not leach out into the system. It's an extra level of security for the craftsman and for the consumer.
That's nice to have when you're working with something like drinking water. And you're also ISO certified, right?
That's right, John. We're very proud to be certified as an ISO 9002 company. To become certified, the company has to meet very strict guidelines on the way we do business. We're reviewed every year to make sure we're adhering to those standards.
That all sounds very intense.
It is, John. But we really believe in our products and we really believe in our service. And ISO 9002 is part of that commitment.
Well, I have to say, this is a very impressive process. Thank you so much for having us in to show us how this unique product is made.
It's my pleasure, John. Come see us anytime.
All right, let's go back now to Master Plumber Ronnie Jackson and sweat some copper. Now we're back with Ronnie Jackson. Ronnie, it looks like you're ready to fire up that torch.
Absolutely. John, let's put our safety glasses on.
Yes, you should always wear your safety glasses and have a fire extinguisher nearby.
Yes, have your fire extinguisher and also be conscious of any flammable materials in the area. I'm going to fire up my torch. We're using propane here. It has a combustion tip temperature of about 1750 degrees. Remember, the solder melts only 410 degrees, so we have plenty of fuel here to do this. We can also use MAP gas, that's about 2450 degrees, or we can use an acetylene tip, 2800 degrees. Both of those hotter fuels are completely unnecessary because we're using Teramet sterling solder, which melts at 410 degrees. It's the lowest melting temperature of any lead-free in America, and it's also the highest in tensile strength. Preheating on an angle, only the depth of the cup. Heating out in this area completely unnecessary. We're getting a transfer of heat from the pipe to the inside of the fitting. This is called conduction. Now let's move back to our fitting cup on the same angle. Now, since the work is at waist level, I need to get down there because we need to begin introducing the solder at the base. So let's go on down here. This Teramet sterling melts at a very low temperature. It's also my temperature gauge. I'm going to test whether this joint's ready to receive solder. I move the torch out and I move the solder in. We're not ready. Now this solder is not a paintbrush. That won't do it. This solder now becomes an ice pick. Where do I want this solder to go? I want it to all go all the way back to the base of the cup. Let's go ahead and push it back there. Test. There we go. Now let's push it like an ice pick. The torch is staying ahead of the travel. Okay? Let's go down here to about 5 or 6 o'clock. Push our solder in, keeping our torch ahead of our wire. And here we go. Pushing in. Capillary action is taking over. All the way in. Now we'll go around to the other side. Dropping down low, about 6 o'clock, pushing like an ice pick. The flame is staying just ahead all the way around to the top. Now, let's do our bridging. Little heat there. We're going to bridge it. We're going to go all the way across. Now we've got a drip at the bottom. we take the cold end of our solder and we knock it off. Now for a more finished look, like a mechanic has been on the job today, I call this the mechanical signature. While it's still in the cooling process, the solder is still somewhat molten. This is completely unnecessary to the strength of the joint. This just gives it a signature, a nice finished look, much like a caulking. And we must do it very, very carefully. We don't want to disturb or move this joint during the cooling processes. Some solders cool very quickly. Some solders cool a little bit slower. Termite sterling is right there in the middle somewhere. But we have found out the solders that cool more slowly bind and embed themselves back in those nooks and crannies. This is where the true strength is. We found out that the solders that cool more quickly are far weaker. Termite sterling has now bound the strength of these two metals together at 7,130 pounds. We're going to let that cool a little bit. And with a damp rag, we'll wipe off any residual flux that's on the outside, give it a nice clean look. But we usually return to that after the joint's cool.
How do you know how much solder to use on each one of these joints?
Well, for a 1/2 inch joint, you need about a 1/2 inch of solder. For a 3/4 inch joint, you need about 3/4 inch of solder. For joints larger than 3/4, the formula doesn't work. You need to refer to the Copper Development Association guidelines.
Ron, you make this whole process seem so easy.
Well, it's really not difficult. If you don't overheat the pipe, but evenly heat the pipe and fitting correctly, use the solder as a temperature gauge, you're going to make some beautiful joints.
Do you need to flush the pipe?
Well, petroleum-based fluxes should be chemically flushed. Water-soluble fluxes just simply flush out with cold or hot water, or leave the flux in there, it'll dissipate in the water. The CDA, interesting enough, will give an extended guarantee if you use a water-soluble flux, but do refer to your local codes.
Ronnie, thank you so much for showing us how to get this job done right. Let's quickly review how we got here. We carefully measured our pipe and cut it square with the run of the tube. We cleaned and etched our pipe using sandcloth, being careful not to touch the cleaned areas with our hands. Then we reamed the inside of the pipe to remove any burrs that might interrupt the flow of water. After our pipe was thoroughly cleaned, we fluxed the areas to be joined, both inside the fitting and outside the pipe. We made sure the system was well supported so the gap between the pipe and fitting was equal all the way around. Then it was time to turn up the heat. We preheated the pipe, then moved to the fitting. When Termite sterling began to flow, we backed off the heat and fed the solder into the joint. To finish off the job, we wiped the pipes down after they'd cooled off. Check with your local plumbing codes if you need to chemically remove any petroleum flux. So there you have it, a leak-free sterling joint. I'd like to thank Master Plumber Ronnie Jackson once again for showing us how to get this job done right.
My pleasure, John.
And remember, a job done right will last the life of the pipe. For Master Plumber Ronnie Jackson, I'm John Roberts. If you'd like more information on soldering techniques or any of the products featured on this video, contact TerraCorp Imaco Incorporated at 800-334-5266 or visit us on the web at terracorp.com.